So if you're watching the video, I think you want to work on these as a warm-up from last lesson. It'd be a good thing to start with. So pause the video and try these out first. Okay, so my class. What should I do with this first guy? Distribute, right? That's what we talked about. Distribute how many things, how many times?
Each thing.
Each thing. I like that, the word each. So then it doesn't matter if there's 2 or 3 or whatever, right?
Each of the 2 into the 3 of the other.
Great, so we're going to do that. Get 3 out from those, and then also 3 out from the others. So leave those in green. So my blue ones, let's see. Sierra, can you help me?
X times X. Isn't it X to the second? Not X to the third.
Yeah, but there's 1x and there's 2 more xxx's.
Oh.
It's cubed, right? All right, then what? Who else can tell me the rest? Taylor, you want to tell me the rest? What are my other blue ones?
So then you would multiply the x times the negative 10x.
So?
Get negative 10x squared.
Yep, and then
x times 2 is 2x plus 2x.
okay, so there's all my blue ones. Let's see, Caden, can you help me with the green ones?
And it'd be 3 times x squared.
Which will be,
One would be 3x squared.
yeah.
Then 3 times negative 10x, which would be negative 30x. Then 3 times 2, that'd be 6.
Sweet. Okay, let's see. Colton, can you tell me what's the same? Are there any like terms I can put together? Colton's saying we can put those together, all right. Nothing with this one? Just x cubed, it's going to fall down. What are those going to be, Tristan? 3 and negative 10.
Would that be negative? No, negative 8, sorry.
Close. You're doing it right.
Negative 7.
There you
Oh, I'm sorry.
You're good, you're doing it right. Okay. And then we can put the 2x and the 30x together. That's negative 28x. We've got plus 6. All these things are unique, different kinds of things. We've got x cubed things, x squared things, x things, and constant things. Okay? So, you guys need to put your computers away. I'm sorry if I'm boring you. We'll get something that's not boring you in 30 seconds. Okay? So, how do I name this? Just to review, because we should be able to name these. We don't want to forget that. How do I name that guy? Cubic, because it's degree 3, and what else?
Tetranomial.
Tetranomial, 4 terms. Very nice, you guys. Okay. How about this one? What's my first step?
Write it again.
X minus 4 times X minus 4.
Plus.
Good.
And then you distribute.
And then we do the same thing we just did, right? So I'm going to do it quickly this time. So x times x, x squared, minus 4x. That one's done. Move on to this one. So I'm going to get another negative 4x there. Negative times negative, positive 16. And I can put these together. Find your teeny mistake, Joe, on that one? See it now? Okay. Let's think about the shortcut formula, because I know some of you guys want to do this fast. You want to be efficient. This has the shortcut formula. How do I go straight from here to there?
Well, we know it's going to be x squared.
Because we do the first thing squared, and then we think about
4 squared.
negative 4 squared is,
Negative 16. I mean,
Oh.
positive 16.
if it's all being squared, it becomes positive. Good. And then double that times that. That times that is negative 4x. Doubled is negative 8x. So I know some of you are going to want to use that shortcut. I certainly would, because I like to be lazy. So feel free. Yeah.
Me and Ricky are arguing on the name of that one.
Oh, yes. What's the name? Good question.
Cubic.
Cubic's degree 3. This
Wait,
is degree
Quadratic.
degree 2. Quadratic. Quadratic trinomial. There we go. Okay, so help me out. How could I do this one? I think we know one way. Distribute what, man?
It's gonna be x cubed.
Oh, it's going to be x cubed. So Caden's trying to do the shortcut formula. X cubed, I agree. That'll be in there.
And then I'm not sure with the rest. I'm not sure with the rest.
There's going to be an x cubed. There's also going to be a 4 cubed. I agree, which is 64. 4 times 4 is 16 times 4 is 64. But there's also going to be, think about how I said this yesterday.
12x. No.
There's going to be more. Okay, and that's the key, is that you realize that there's more. So there's one way we know how to get that more stuff, and what is it? How could I start this guy out? Rewrite it how, Taylor?
Having x plus 4 3 times, so
3 times. Very good. So here's the long way to do this. Some of my Algebra 2 students, they can choose how they like to do these. We're actually doing this right now, except we only did it for like a piece of one day. They can choose if they want to do it like this, by all means, and some of them do it like this. So you guys can, of course, do it like this. So once you've got that, I think you do what we've been doing. You start distributing, Mr. Miller. So you take 2 at a time. It doesn't matter which 2, so you could start with these 2 and go with that. You could say x times x. So I'm ignoring this, but put it out of your mind, okay? So x times x, what's that?
x squared.
All right. X times that 4.
4x.
4x, nice and easy, right? We did that guy. Now we're going to do these 2.
Plus 4x.
Great. And we're going to do 16. That was the first 2. We've still got this other pink dude hanging out, attached to the side, yeah? So there's some like terms, so we put those together. It's 8 x's.
Oh man, that's cool.
Cool. And then you've got to do what? I heard it. You have to do it again. So this is kind of a long process, and it's getting nice and long in a line like Sierra predicted, kind of, right? So let's do it just for the heck of it this time. You can do it this way. So I'm going to say this times this. X cubed, right, ladies? X times x times x. It's x cubed. What's this going to be?
4x.
4x cubed.
4x
Squared.
squared, right? There's only the 2 x's
Yeah.
here.
I get the 2 and the 3 mixed up a lot.
You got it though? I mean, you just
Yeah.
got to keep telling
Got it.
yourself. Okay. So that one's done. Now we got to move on to this one. 8x squared. Very nice. This one. 8 times 4 is 32. Any x's on that one, Tristan?
Yes.
How many?
1.
Just 1. Okay. That one's done. Now we're going here. We've got a 16 and an x. And 16 times 4, you might have to whip out your calculator.
That's 60.
I'll do it. That's 64.
Yeah.
Like terms. Let's see.
X cubed.
I'll try to color code them here.
X squared.
Got these ones, right?
So
So how many x squareds are there?
12x.
12x squareds. I like it. You're starting to say it right now. There's 2 terms that have x squared. There's 12 of the x squareds. Right? How many of the x's? 2 terms. How many of the x's though?
48.
Might need our calculator again, but isn't that 48? Cool. Okay, so there's the final expanded answer. That's the expansion of this binomial cubed. Took a lot of work, right? Like, it's a fair amount of work. But you can totally do it that way. I think it's good practice while you're getting your mechanical skills in this class developed. Okay, so it's good practice. But what about this one? X plus 2 to the 7th power. How would we do that then? X plus 2, X plus 2, X plus 2, X plus 2, 7 times, and then we'd have to do 2 at a time, and then simplify, and then do it again with another one, simplify, and then do it again with another one, and simplify. Oh my God. It'd be like the worst thing ever, right? Like, I don't want to do that. I really don't. It's not my cup of tea, okay? So I'm guessing it's not yours either. If it's cubic, you can handle it. It's good practice. Makes you stronger. But I just don't want to do this one. So wouldn't it be nice if we could just go straight from here to there?
Yeah.
And luckily there's a way to do that. So how about we'll do it with this one and then we'll do it with that one next. So I'm going to erase this for a moment. Just give us some space. I'm not going to do any of this stuff. I'm claiming we can, with 1 or 2 steps, go straight to the answer. That's how I do it. So let's see, do I have a blue? I need a blue. Ah, it's over there, okay. So, how are we going to do this? Well, I think we use this thing called Pascal's triangle. You guys heard of this thing? It's used for a lot of different things. Maybe this is your first time seeing it. Looks like this. Maybe someone showed you this.
Yeah.
Cool! I mean, you can use Pascal's triangle for a lot of things. This is one of the things it's nice for. So you start drawing this like little pyramid of ones. And after you get to the second row, you can start adding them. So this one and this one is a 2. That's the 2 from our shortcut formula. Because if we just did this squared, didn't we do the first thing squared, the last thing squared, and 2 of the things times each other? So if it's cubed, I think you go and you use this row instead. If it was 4th power, you'd go and look at the next row. If it was 7th power, you'd go down until you have the 7th row. Does that make sense? So let me show you how you're going to use this row. Here's how you do this. You pick the right row for the cubed. I pick this row. And by the way, you don't have to do it this way. I'm just showing you an alternative that makes your life easier. If you want to do it the long way, I'm not going to have very many problems on the quiz that are very, very big. So you can kind of do them either way. Yeah? But for those of you who plan to be something of in the future, I think you're going to like this. Okay? So that's the first thing. That's all I need Pascal's triangle for. We'll come back to it on the next problem. And then you guys were saying this at the beginning. You do x cubed. You know what, I'm going to use a different color. Just keep this straight. And then you walk that down. And that's it. The x part's done. And then you look at the last thing, and didn't we say at the last thing you guys were telling me to do like a 4 cubed? Where do you think I put the 4 cubed? Over on the other side. And I walk that up. And the 1 powers I don't really need, right? It's just 1. So. And if you do that, that's this. You see it? 1x cubed. It's x cubed. 3 times 4 is what? 4 squared is what? 16 times 3. 4 cubed. That's the answer. That's it. Boom, done.
Literally.
Okay?
If only I knew how to do this.
So, yeah, this will make your life easier. So let's try it one more time just to practice, and then you can use it or not in your problems. I don't care. You do what you gotta do, I'll do what I gotta do. So what do we have? X plus 2 quantity to the 7th power? So I think we need a bigger Pascal triangle, so it's pretty easy. You don't have to memorize this, you just like draw it. Just like, okay, then once I have 2 1s, I add them together. Once I have a 1 and a 2, add them together. 1 and a 3 is going to be, 3 and a 3 is going to be, I don't think this is far enough, is it? So that's for 4th power. We're going to have to go down several more rows. Let's just make this a little shorter today instead of 7th power. I mean, that'd still be pretty easy, but let's just go 5th power, save board space, okay? So 5th power is going to be 1 more. You guys help me. What's here?
5.
And here? And here? And here?
5.
Okay, so those are my coefficients. 1, make sure you leave lots of space. Okay, lots of space, lots of space. 1, 5, 10, 5,
10,
Missing a 10.
missing a 10, sorry. Gonna erase my triangle, dude. So if you just draw the triangle once, I mean off to the side, you're gonna be good. And then what did I do next after I got those? Joe, can you help me? I need some help. What do I do with the X? There's no distributing. X to what power first? The 5th. Let Joe answer. What's this one going to be then? Joe? X to the 4th? How about here, Joe? Going down the mountain. Yeah. And I'm sure we've all got it. Cool. That's all there is to this. Thank you, Joe. All right. And then over here, what am I going to put? To the 5th, okay.
Oh, hold on, where'd you get that?
It's right there.
Oh.
The two
Oh, okay.
Think how long this would take the other way. It would be a nightmare. I don't want to do it the other way. Would any of my students in advanced classes do it the other way? No.
Through a desk.
No, they wouldn't be in those classes anymore. They'd be like, I hate math, I'm done. So,
I have a question. Assuming you left it to the 7th power, like how do you determine those numbers? Like you know how you have 1, 5, 10, 10.
keep
5.
going with Pascal down.
So if you had 7,
You would go
We had-
7, 5, 4,
There'd be
3,
1. What would be here?
2. Oh, sorry.
5,
6,
15,
15, 20.
15.
If you just draw it once on your paper, you don't have to do it every time, you know what I mean? Just draw Pascal's triangle out pretty far once and you're set. I'm not going to ask you to do any real big problems anyway, so you don't have to worry for now. Okay? Good questions, Sheridan. All right, so the last part here is just make sure you put some pluses. These are all separate terms. If there's negatives involved, it'd be a little different. Maybe we'll do one like that next week. We'll see. This is plenty for this year. So then you got to multiply these out. You can use your calculator to help you. I don't think we need it much here. What's 5 times 2?
10.
So 10x to the 4th. What's 10 times 4? Because that's 4, isn't it?
40.
40. Here we've got 2 cubed. 2 times 2 is 4, times 2 is
8,
8 times 10.
80,
2 to the 4th, that's 8 times 2. 16 times 5. We might need our calculator. What's 16 times 5? Help me out. I think you guys have calculators somewhere, like, right?
What'd you ask?
16 times 5?
That'd be 60.
It's 80.
I think it's 80, yeah. And 2 to the 5th, you can of course use your calculator, but I encourage you to count these. You need to know them for next year. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2, that's 32. Answer, done. That would take at least the entire board, maybe all my boards, to do it the long way. Yuck. So use this shortcut to your advantage. Okay, so just like the problems we had before, let's find the area and perimeter of this trapezoid. I don't think we went over the formula for that though, did we? For a trapezoid? Do you? Cool. We can do the perimeter at least, right? Okay, so put your like terms together and you're done. So how many x's? We got 3 and 3 more and 2 more. Is that 8? We've got -4 and -16. There you go. Let's stick some units on here. I'm going to say this is feet. So this is feet. Okay? Area. So Lindsay, you said you had the area of a trapezoid. Do you know that one?
I think so.
What is it?
I have my notes, it's just base times height. I don't think that's...
So we could play this trapezoid game a lot of different ways.
Can we pick the easiest?
So I could derive it. How about I just tell you the formula today, and then another day we'll look at why the formula is what it is. It's almost like a triangle. What's triangle again?
Half of base times height.
Half base times height. Well, the problem is a trapezoid has two bases. So instead of being half a base times a height, it's kind of like the average of the bases. Since it has two, this is the easiest way to remember it. It's half the bases, so it's like the average of the two times, guess what? The height. And I don't want to bore you too long today. Or maybe it wouldn't be boring. We could chop up that trapezoid and see where this comes from pretty easy. It's not very hard. So we'll chop it up maybe Monday, okay? But for right now, let's just plug this in. So bases, the bases I think mean the flat parts. The parts that are parallel. So I think I've got to add up this one. Which one's parallel to this one? Which one's parallel to this one? Yeah. And how high was it? Okay, so there's an expression right there. If you can at least do that on like the exam, you're going to be in pretty good shape. But I'm guessing they probably want us to like combine stuff and multiply stuff. So let's just do it. And I'm going to go a little quick since we've done a bunch. So order of operations says like go inside parentheses first, right? So that's like done. There's like parentheses here though, whether you know there are or not. So what's inside there? There's really 6x and minus 20. Good. And now I've got a 2 underneath both these, so let's chop them both in half. What's half 6? And half of the 20 is, and it's a negative, right? And I can set here and let you guys do that yourself. Why don't you? Go ahead. Expand that out. So here's what I think you should have got. Check your answer. Most of you had something close. This times this is 3x squared. This times this is 9x. And here we've got a negative 10x. And here we've got a negative 30. Those are like terms. 9 minus 10 is negative 1. Okay? And that guy, let's remember, what the heck is this thing supposed to be representing? It's supposed to be representing an area, so what kind of units should it have? We had feet, so it's going to be square units. That's what it takes to cover up a shape. We're thinking about what it takes to cover this up. And of course, this is not an exact number. The power of this, though, is now we could take any value of x, and we know the area immediately without having to redo it, okay? And also just like kind of practicing some of the stuff we've done. All right.